not gonna lie, this one is pretty awful because it really goes far, far away from the basic trig function. All right, so your original, kind of ignore the margin stuff. Your original, if you had an original cosine graph that was not, we can tell that this one is not anywhere near the origin. It's higher, it's shifted over, right? This is not a standard cosine function. This is a standard cosine function that goes from 1 to -1. It starts at 1, 0. It's first crosses the origin at pi over 2. It swoops back up. Like, this is a nice, basic, standard cosine function. Now, in the textbook for lesson 71, these were very helpful little definitions. So the period is the pattern. So the distance from one peak to the next. So it's, for a standard cosine function, a period is 2 pi. All right, so again, that's where we're gonna get crazy from here. But that is why our C is 2 pi over the period in radians. And again, whenever we're dealing with anything with pi, basically, instead of decimals, or degrees, I mean, that's when we're dealing with radians. That came up in one of the ones I did for you a while ago. All right, so the reason I said this one is awful is because if you look at the peaks don't cross anywhere that we can identify until this one. So that means you have to go 1, 2, 3, 4, 5, 6, 7, 8 tick marks over. So that's where I started doing this. At 8 tick marks times pi over 4, but that's not one pattern, that's 1, 2, 3 patterns. So we have to divide it by 3 in order to get our actual period. Super duper fun. So I didn't mark. So this would have been an actual period. This would have been 1 period. So we technically have 3 periods by the time we can get somewhere that we can measure. So that's why we have 8/3 times the pi over 4. The pi over 4 is our measurement for each of our tick marks. So we just do the math. So obviously if you cross that out, that eliminates, that becomes a 2. That's where you get your 2 pi over 3. So 2 pi over 3 is our period. To find C, you need 2 pi over the period in radians. So we have, we have 2 pi over the period in radians. Again, our period in radians is, 2 pi over 3. So when we do our math, 2 pi divided by 2 pi over 3, multiplying and dividing fractions means we have 2 pi times the reciprocal. Our answer is 3. So technically easy, except that you have to really understand what was happening in the graph and expand it out and all that stuff. So hopefully that helps you.